You recall last time, JavaScript is the world's most misunderstood programming language. This is its most misunderstood feature. It's also its best feature. It's one of the best features in any language. It was a fairly unusual thing at the time that JavaScript introduced it. Since then, this has become pretty popular, and you see it in virtually every language now except for Java. Java's having a tough time keeping up with its stupid little brother. So today we're going to talk about functions. This is really important. This will be the most important show in the series because this is what this language is ultimately about. And in my view, this is what programming is ultimately about. There are a lot of people who use JavaScript who hate the language primarily because they don't know what the language can do, and they're trying to do things the way they would in a language that this isn't. And so that doesn't work. If you look at other languages, they'll have things like methods, classes, constructors, and modules. Many of these will have their own keywords. JavaScript doesn't have those. It just has functions. But it turns out function is all you need. Function can do all of these things and more. So if you don't understand what functions do in this language, you really can't be very effective in this language. JavaScript has a function expression, which produces a function object, which you can then execute, and it'll do what it does. So a function expression starts with the function keyword. It can then have an optional name. That name can be used by the debugger to help you read stack traces and understand where things came from. That name can also be used to allow the function to call itself recursively. That can be a useful thing. We'll talk about recursion later. It's then followed by a set of parameter names wrapped in parentheses, separated by commas. This is how the function can receive arguments from the outside. And then it has a body, which is a sequence of statements wrapped in curly braces. And that's a function. So a function expression produces an instance of a function object. If you ask what the type of this thing is, it'll say it's a function. Function objects are first class, which means that they can be passed as an argument to another function. They may be returned as the result value of a function. They may be assigned to variables, and they may be stored in objects and arrays. And objects or functions in this language inherit from function.prototype. So functions truly are objects in this language. And because they can inherit methods, it means that functions can have methods, which might sound odd, but they can do that. Functions have var statements in which they can declare their local variables. Var doesn't require types. In fact, there's no way to specify types. So you just say it's a variable, and you can store in it any value that you want. A variable declared anywhere within a function is visible everywhere within a function, which is not in itself a bad thing. It's actually a good thing, but there are problems associated with it, and we'll get to those later. The var statement does a weird thing called hoisting, where it gets split into two pieces. The initialization part of it stays where it was and turns into an assignment statement, and the declaration part gets hoisted to the top of the function. So if you declare a variable within a block, like in the consequence of an if statement, if you're used to the idea of block scope, you might think that that variable will only be visible within that block. But because the declaration gets hoisted, it gets moved out of the block and to the top of the function. Yeah?
So does it mean if I have more than one declaration, they will be all
combined into one? They will all go to the top.
And so they will combine into a single one for the same variable.
Right. So if you declare the same variable several times, like in nested blocks, they all collapse into one variable. Which is terrible, right? It is truly terrible. And we're going to encounter a lot of terrible things, but that's not even the worst of them. But it is definitely a problem and something you want to watch out for. Now, there's also a function statement, which can be a shorthand for creating functions, and unfortunately, it looks exactly like the function expression. So it's really easy to confuse the two. And for the most part, they're the same because they both produce function objects. But they're not the same. And so anytime you have things which look to be the same that are not exactly the same, you can easily have confusion, and you do here. The function statement is distinguished two ways. One is that the name that was optional in the function expression is now mandatory. And it has to occur in statement position. It cannot occur in expression position. So where it occurs rather than how it looks determines what the thing is going to do, which is certainly confusing. So a function statement is shorthand for a var statement with a function value. So if you have function foo as a statement, that expands into the creation of a variable foo which receives the value of that function expression. This is very different than in some other languages. For example, in most languages, the definition of a function is a static thing. It doesn't actually allocate any memory. It just is this thing that is declared. But in JavaScript, a function declaration is not a declaration. It's actually executed. Doesn't happen at compile time. It happens at runtime. It gets run and causes variables to get inserted into the environment, those variables getting the value of what the function would have been. New function is a completely different thing. And I recommend you not use new function. New function takes a string so that it gives you access to the compiler. Generally, there are very few instances where that's a good idea. Lazy loading of code being probably the only good one. There are lots of bad ones. Generally, if you want dynamic code in your program, it's better to figure out how to do it with functions as values rather than trying to synthesize stuff from strings. So which one you get, there's one bit of complexity that I missed. So the function statement expands into a var statement, and then the var statement gets split because of the hoisting. And the initialization also gets hoisted. So function statements are really weird in that respect. Because of its weirdness, the language standard says that you cannot declare a function statement in an if statement. It has to be at the top level of a function or the global space. Now, it turns out every browser lets you do that anyway. But because the standard says you can't, they each decide to have that mean something different. So my advice is don't do that. If you really need to declare functions conditionally, use the var form with function expressions, because the standard does allow that, and that behavior is consistent over all of the browsers. The function statement should only be done at the top level. Right, this is a different name. It could be a different name. In this case, the system will generate the same name. So the use of this name is for use in the debugger. This is the name that you'll see in the stack trace. And if the body of this function wants to call the function recursively, this is the name it will use. So we have function expressions, function statements that look exactly the same, and which one you get depends on where you are syntactically, whether you're in statement position or expression position, which is certainly confusing. So that one expands into that one. So one of the best inventions in the history of programming languages was the notion of scope. This was something that was introduced with Algol 60, which was maybe the best design by committee in history. Most other design by committees have not been as successful. And I don't know why that one was successful. Lots of committees had very smart people on them, and certainly the Algol 60 committee had very smart people in it, but somehow they produced a significant advance in programming languages. Maybe it was because they did their work kind of early, and the good ideas were there to be found, but they found them first. And it was very influential, and it found its way into virtually all other languages. So block scope means any place you have a block, which in most languages is designated by a pair of curly braces. It means any variables declared in that block are not visible outside of the block. And if you're using one of the languages that allows for nesting of blocks, it means that if you declare something in the inner block, it doesn't leak out to the outer block. That's really good. That's a brilliant idea. It turns out JavaScript doesn't do that. JavaScript, because of that hoisting thing that it does, only has function scope. So any variable that you declare anywhere in a function is visible everywhere in the function, but is not visible outside. Now, it turns out function scope is adequate. You can write good programs just having function scope. So the fact that JavaScript doesn't have block scope is not by itself a problem. What is a problem is that its syntax looks exactly like the syntax of languages that do have block scope. So if you're coming to JavaScript from C or C++ or Java or C# or one of lots of other, PHP, lots of other crappy languages that look like that, you may very well expect that block scope's going to work the way you're used to because it appears to do that, and it doesn't. And because function scope and block scope do not behave the same way, and because particularly JavaScript's implementation of function scope is deeply flawed because of the problem we talked about where you can declare a variable twice and get no warning. So you might think you have two distinct variables in different blocks, but in fact they are the same variable. That is a source of bugs. So yeah, that's bad. So in JavaScript, blocks don't have scope. Only functions have scope. Variables defined in a function are not visible outside of the function. And so you don't want to do things like this where you have blocks with the same variable name, which is legal in some languages. Probably not a good idea in any language, but most languages allow this. JavaScript will assume that both of these var i's are the same. So this will never finish because it's constantly resetting itself every time through. So because of this, I recommend that in JavaScript you declare all of your variables at the top of the function. Now in a block-scoped language, you would say, no, you should declare them in the innermost block, which is common to all references to that variable, and probably at the site of first use. That is really good advice in a block-scoped language. It is terrible advice in a function-scoped language. So in a function-scoped language, of which JavaScript is the only one that I'm aware of, you want to declare all of your variables at the top of the function because that's where they're being declared anyway, because they're being hoisted. So no matter what you write, that's what's happening. So you want to write the programs to look like what they do. If the program looks different than what it does, then it's very easy for people to misunderstand what the program's doing and make mistakes. There's a similar thing because of the way that functions get hoisted, which was intended as a convenience to make it easier to do things out of order. But because this is not a static language, it's a dynamic language, and it's actually rearranging things in a weird way, it is problematic. So I recommend declare your functions before you call them. Language doesn't require that, but good practice does. Functions have a return statement, which is used to conclude the processing of the function and to optionally return a value. So return has two forms, return the value of an expression or return nothing. Returning nothing doesn't actually return nothing. It will return the value called undefined. So arguments is not an array, it's an object with a length property. So the length property is useful. It tells you how many elements are in the array, or in the thing that would be an array if it were an array, but it's not an array. So it means that there are things that you would like to be able to do to an array that you can't, like slice it, or, take a subset of it and pass it. You can't because it's not an array and doesn't have array methods. You might want to concatenate it with something else. You can't do that either. So there are weird workarounds that you have to do that. Even worse, there is a one-to-one mapping between the arguments array and the formal parameters. So if you change an element in the arguments array, the corresponding parameter also changes. And if you change a parameter, the corresponding element in the array changes. And if you do something really wild like delete or slice off one element of the array and cause it all to shift over, all of the parameters will shift, which is crazy. all of the people who are writing JavaScript engines, I think pretty universally they all hate JavaScript. But the thing they hate most is this crazy arguments thing. Because they're trying really hard to optimize and make things go fast. But anytime there's an arguments array in scope, then they have to be prepared for this insane weird stuff to happen, which has to make things go slow. So generally we're trying to avoid using arguments at all. In the next edition, we'll have new syntax which makes it obsolete. That'll be much nicer to use. That will actually produce real arrays and much smaller code and all of that. But that's years off, so we'll talk about that another time. So here's an example of how it could be used. Say I want to have a sum function which can take a variable number of numbers as its parameters, and I want to then return the sum of them. So I can use arguments.length to tell me how many items I'm going to loop through, and then I can use the array notation to get the items, then add them up. Yeah, I recommend, well, for I in does not guarantee what order it's going to produce the results. And it can also produce results which have subscripts which are not numbers, which could certainly screw you up here pretty royally. So you generally don't want to depend on that. Just use the conventional array notation. That'll be much more reliable. So the other pseudo parameter you get is this. This is the parameter that contains a reference to the object of invocation. This is used for object-oriented programming. If you execute a method in an object, this will be bound to that object. And this is one of the dimensions of code use in JavaScript, that you can have a single function which gets inherited by many objects and will be able to work on all of those objects, and this tells it at any moment which object it is working on. That turns out to be a good thing. We invoke or execute or call functions using the parent suffix operator. Those parents can surround 0 or more expressions separated by commas, and those produce the values that will be passed into the function. And all of those will get bound to the arguments array as well. If a function is called with too many arguments, the extra arguments are ignored. So if you asked for 2 arguments, but 3 were passed in, it just ignores the extra one. Although that extra one does get attached to the arguments object, so you can still get it if you really need it. If you call a function with fewer arguments than it has parameters, then the unfilled parameters get initialized to undefined. So you don't get an error in either case. If you have a mismatch in the number of arguments and parameters, it will still work. And there's no type checking at all. So if the types of these things are important, you have to explicitly check them yourself. There are currently 4 ways to call a function. In the future, we'll probably add more, but right now this is the set. So there's the function form, there's the method form, there's the constructor form, and the apply form. And I'll talk about all of these. Let's start with the method form. So this is the basic operation that you have in object-oriented programming. We have an object or an object value, something that generates an object reference is in the first position. Then we can say dot and the name of a method, or we can say subscript and a expression which evaluates into the name of a method. These two are interchangeable if the method name is an identifier. It's sort of unique in this language that a method name does not have to be an identifier if you're using the square bracket notation. But in either case, you then have the bunch of parameters, and the function is called. This will be bound to this object, whatever it was. And this allows methods to have references to the object of interest. Then there's function form, which is the same except it doesn't have the prefix, which is a reference to an object. So this says we're just going to call the thing as a function. And in this case, this isn't set to an object because no object was specified syntactically. So instead, this is bound to something else. In ES3 or in ES5 sloppy mode, it was bound to the global object, which is maybe the worst possible thing it could be bound to, because the global object is dangerous, and in this case, we're binding to it, and there's not a good reason to be doing that. In ES5 strict, this gets fixed. It gets bound to undefined, which is not useful, but at least it's not dangerous. What it should have probably bound to is to the this of the function that it was nested inside of. So we'd still have lexical scoping. But lexical scoping doesn't apply to this. So every function has its own this. And if you have a helper function inside of a method, and you'd like that helper function to be working on this, it doesn't see it because it gets its own this, which is either undefined or the global object, which doesn't help. So what the outer function can do is create its own variable, for example, that, and assign this to that. Now that will be in the lexical scope of the inner function, and so the inner function can then get through this through that. It should not be necessary to do that, but it is. There may be a fix to this in the next edition, but that doesn't help you now. So ES5 has a bind method, which allows you to take a method and an object and produce a function which emulates that method invocation. The bind method is not available in ES3. However, it is easily implemented in the ES3 language. Yeah, so you could add something to function.prototype.bind, which would have the same behavior as what happens by default in ES5. That was done very intentionally. That in ES5 we wanted to make it possible for you to write programs in the new dialect, but have those programs run backwards, and that's hard to do. So we tried to design most of the improvements to the language so that you could fill them in. It's sometimes called polyfilling. And that way you could take advantage of the whole language. That the ES3 implementations might run more slowly, but I think that's just fine. I think the performance on ES3 should be awful, but at least it would work. Then there's the constructor form. Constructor form looks just like the function form, except it has the new prefix. And we'll talk later about how that works. This new was chosen specifically to look like Java, but what it does is radically different than what Java's new does. So it was supposed to make the language friendlier for people who are used to traditional object-oriented programming. That didn't work, but we were stuck with this syntax, which is problematic. We'll talk about the problems later. Then there is the apply form. Because functions are objects, they can have methods. And so two methods that every function have are call and apply. We really don't need both of them, but we've got two. And given that what they do is so similar, maybe the names should have been more similar too, but they're not. So they allow you to take an array and pass it to a function, and you say, take that array of values and spread them out over all the parameters that go into the function. And while you're at it, you can specify what this will be for that function as well. So there are times when you might want to, you don't want to, but anyway, there's the possibility of using these methods. So there are 4 ways of invoking a function, and the major difference between them is what happens to this. When we use the function form, it gets bound to either the global object or undefined, where what we really wanted it to be was the outer this. In the method form, it gets bound to the object of interest. In the constructor form, it gets bound to a new object that's being constructed. And in the apply form, you specify what it gets bound to. Yes, so you could call your helper function using apply, passing your this in through that this. That will work. But it is work, right? It's you probably don't want to be doing that much work. Closure is not an issue in that case because it's not getting this from the outer closure. Functions in JavaScript and in virtually all other programming languages are not like mathematical functions. A mathematical function is really a mapping. It's not computation. But in most programming functions, we have side effects. So the function is doing more than determining a value. It's probably changing state and doing other stuff. And there's some debate about this in the community. There's some who say we should be programming using pure functions. And there's certainly some good reasons to say that. Pure functions are much easier to reason about because every time you call that function with the same arguments, it's going to produce the same result. Whereas very often in the functions we're writing that are causing mutation and side effects, every time you call it, it's going to do something different. And so that makes testing, at least, much, much harder. Also, if you're dealing with threads, if you're in an environment that has only pure functions, you don't get races. And that's a good thing. Races or threads should not be used in systems that do mutation. But we tend to mutate a lot. And the world is mutating. So it turns out having mathematically pure functions in applications is really, really hard because everything we do changes. And if you're in an environment in which nothing is allowed to change, it just makes things really difficult. So we get the easier thing. So historically, what we call functions were called subroutines. The call and return paradigm was invented by Grace Hopper. She had a library metaphor where she imagined each subroutine as being like a reference in a library, and you would call for them, and they would then be compiled together and put into your program. So when I first heard of calling a function, I thought it didn't make any sense. This is nothing like a phone call, and that wasn't the kind of phone call it was. And in other languages, they've been called subs and procedures and procs, funcs, functions, and lambdas. Lambdas is where it got interesting, as we talked about last time. So why are there subroutines? The first reason was code reuse. It was observed that you would often do the same thing several times in a program, or the same thing in many programs. So if you could somehow factor that out and put it in one place, that allowed for some reuse. As you can reuse code, it means you're writing less code, and that means you're being more productive, and that could be a good thing. Later, it turned out that it was important for decomposition. So independent of whether we're going to be reusing things, breaking stuff down into smaller bunches of stuff made it easier for us to manage. Computer doesn't care how big a function is, but it turns out it matters to us because we can only deal with things of a certain size because of our limitations. They can provide modularity, so you can isolate one part of the program from another by encapsulating stuff inside the functions. We're finding that it just becomes easier to express ourselves. You can use functions to essentially design a language which is the ideal language for representing the solution to the problem that you have. So, as you're developing your system of functions, you're making the language for solving your problem. But functions get really interesting when we start getting into higher order functions, where functions take functions as parameters and functions return functions as results. And it turns out this is where it gets really interesting, and we're going to talk a lot more about that today. Then the other thing that functions can do is call themselves, and it's called recursion. And this was a scary thing for a lot of programmers at one time, that the idea that you have cyclical definitions is itself suspicious. The things it defines in terms of itself, that's inconsistent, that can't possibly work. It turns out it's really expressive and nice. But there's a dark side in that if a function is recursing and gets out of control, it'll go forever. But you have that same danger with loops, so it's not a unique danger with recursion. So one of the best examples of recursion is the quicksort. which it's a way of sorting an array. And the definition of it as a recursive function is so incredibly simple that it's just amazing, where you divide the array into two groups. So you put all the little things on one end and all the big things on the other end. Then you take each of those groups and call quicksort on that, and then you're done. It's amazing. It'll just go through and then partition the stuff. Now, it turns out it's really inefficient if you do it that way, that at some point you'll want to change to another sort. But for doing the big partition, quicksort is amazing. And it was possible because of putting recursion to algol, which was a controversial thing at the time. But today, all languages have recursion. A guy named Tennant wrote a book called The Principles of Correspondence, which was an analysis of programming languages. And one of his principles was the principle of correspondence, where he showed that in some languages, parameters and variables are kind of the same thing. And so in certain cases can be made to replace each other. So here we have two implementations of the factorial function. They both produce exactly the same result, but in one of them, the result is a variable, and the other, the result is a parameter. But otherwise, they're the same. Some people have used this as evidence of a desirability to do a completely different thing in languages, which is to be able to take any expression or any statement and wrap it in a function expression and then immediately execute that function expression without changing the meaning of the thing. And it turns out in JavaScript you can almost do that, but there are some cases where you can't. Those cases are the statements var, function, break, continue, return, because they change their meaning based on what function they're in. So if you take them out of your current function and put them in a nested function, their meanings change. And then this and arguments, the pseudo-parameters, their meaning is also specific to the function they're in. So if you take them and put them in a different function, they are no longer mean what they meant before. But other than that, correspondence holds, that you can wrap stuff in a function and execute it immediately. And we're going to be doing this a lot. So we've got a function here that we define. The function expression returns a function value, which we then immediately invoke, the parents at the bottom. This turns out to be a useful thing in JavaScript, and we're going to do some of that today. So the best idea in JavaScript, I think the best idea in the history of programming languages, is closure. This was something that entered the world with Scheme. And it was an idea that was sort of kicking around for a long time, but no one had ever, prior to Scheme, put it all together. It depends on having functions that can nest, and it can depend on functions that are values. And it also depends on scope, the block scope or lexical scope that we saw earlier. And we saw at different times in history, a language would get two of them, but never got the third one. Like C can have functions as values, and it has scope, but they can't nest. And Pascal could nest functions, and they were lexical, but they weren't first class. You couldn't store them in variables. JavaScript was the first mainstream language to put all of these together. And the reason why it took so long was because of stacks. One of the inventions that came as a result of algol was the idea that we can use stacks to represent blocks, and use also to represent call return sequences. And at a time, that was a radical idea. For example, Fortran couldn't do recursion because it was developed before stacks were invented. But later languages could. And so you see things like Intel CPU architecture contains pushes and pops, in the instruction level, that implementing stacks. But it turns out stacks don't work for this style of functions. You need to be able to walk away from that kind of stack discipline, and you also have to embrace automatic garbage collection. And until recently, that wasn't something that most languages were prepared to do. But JavaScript did it, which is amazing. So the context of an inner function includes the scope of the outer function. And the inner function enjoys that context even after the parent function has returned. This sounds weird, so what did I just say? So function scope works exactly like block scope. So if you have nested blocks, and you've got a variable in the innermost block, the innermost block can use it, but the outer block can't, and so on. And functions in JavaScript work exactly the same way. So if you have nested functions, the innermost function can have variables that the outer function can't see. Where this gets weird is if the inner function can survive the invocation of the outer function. The most trivial way to make that happen is have a function return a function as its value. So the function it returns will be an inner function, and because the outer function has returned in the process of birthing the inner one, the inner function survives the invocation of the outer one. But it continues to close over the variables that were in the outer one. And so that means you cannot rely on stack allocation anymore because the inner one still lives where the other one should have gotten popped off. And so that's why this brilliant idea took such a long time to get to the mainstream. And again, JavaScript did it first. Every time you call a function, you generate a block of memory which will contain its variables. And that record will contain a link to the activation record of the parent function. And will also contain a link to the activation record it needs to return to when it is finished. No reference counts. It requires a garbage collection because you can very easily generate cycles if you're using reference counts. So reference counts are not reliable in this kind of a language. How do you garbage collect? There are a number of ways to do that. The simplest one is mark and sweep, where you start with all of the things that you know are still alive, and you just go and follow all of its pointers to everything else until you've visited all of memory, and any memory that you did not visit as part of that process as garbage can be reclaimed. That sounds really inefficient. There are other techniques which are more efficient but harder to describe. And so you don't notice it. In some languages, in some contexts, after running for a while, everything will stop while the garbage collection runs, and you can see noticeable pauses. In running in JavaScript, I've never observed those pauses, so I doubt that you have either. It's just really good. Yeah. There are now tools for determining if you have memory leaks or determining what your memory is doing. For example, there's stuff in Chrome, which is quite good. I'm blanking on the name, but there's stuff. There are facilities, and most of the other browsers now have similar sorts of forms. Okay, so I'm going to show you an example of this stuff. So I'm going to start with a really trivial function called digit name. It will take a number as a parameter, and it will then return the name of that number as its result. Okay, so I have a global variable called names, which is an array of strings, and it will take a number and look it up. So if I call digit name with 3, it will return the name 3. So everybody clear on how this works? It's like one of the most simplest programs. Now there's a big problem with this, and that is that names is a global variable. JavaScript does not have a linker. So the way independent pieces of programs cooperate is they all get dumped into a common global space. So all of the variables, all the global variables and global functions that everybody creates all get in the same space, which has huge reliability problems. If anybody else contains something called names, and why not? It's a common name, and a lot of our programs deal with names, so you might expect that could happen. Either their code's going to fail, or my code's going to fail, or maybe we both fail, and we're going to interact in a bad way. And on the web, at least, it's impossible to test for that, because you cannot anticipate all of the code you're ever going to have to run with, particularly if you ever have to share a page with ads. some of the worst code you have ever seen gets downloaded with ads. And there's no way you can test against every ad that might ever be written. So you really need to defend against this, but you can't do it by testing. You have to do it by design. You have to mitigate the use of global variables. You have to eliminate them as much as possible. So here's another way I could have written that. I'll say names is now a local variable in my digit names function. Otherwise, this program's exactly the same as the previous one. And this works because of function scope. That names will not interact with any other global names, and so I have avoided that hazard, so that's good. Unfortunately, I've introduced a performance problem, because now every time digit name gets called, it's going to allocate memory to initialize an array containing 10 strings, of which it will extract only one, which is a huge waste of time. Now, an optimizing compiler might observe that this variable is invariant over invocations, and so might want to optimize that out. But optimizing compilers can take many minutes to do their work. And on the web, we don't have time for that, right? We want our pages to start instantly. So we'll probably never see that level of optimization in a JavaScript compiler. So we have to do the optimization ourselves. And it turns out it's easy to do. So I've wrapped my function in parentheses, and it is now going to return a function that is going to have access to the names, okay? And what I'm assigning to digit name is not this function, it's this function, because I'm executing the outer function immediately. Okay, so the result of the outer function is the inner function. So that gets stored into digit name. And because of closure, at that point, the outer function has returned. This is the case we were talking about where an outer function returns an inner function. It's returned. This survives stored in the global digit name variable, so it will continue to work. This is the most important thing I'm ever going to tell you. So it's really important. Everybody's got to get this. I don't want to go past if anybody has any questions about what's going on. Everybody clear? This is the key. Once you get this, then a whole bunch of stuff becomes possible, but you have to understand this. So let me rewind this and look at it from a slightly different point of view. So this is the original problem we saw, where we've got the global variable. Remember earlier I was talking about how you could take any bit of code and wrap it in an immediately invoked function and not change its meaning, right? So I did that. So instead of assigning the function to digit name, I'm wrapping that function in a function that I immediately execute. Okay, this does the same thing as the previous one. Everybody clear on that? Yeah. Now I'm going to do one more trick. I'm going to move names and put it inside of that function. So all I've done is move the global variable from one level to another. That's it. So, you can do that. And this produces that same program. Everybody still with me? Okay. In the future, I'm going to throw a lot of functional stuff at you, and it's all going to require that you understand how this one worked, because the set of things that we can do that expand on this are amazing. Now, there's a pattern that I've seen out there that's been called the lazy pattern. And it assumes that the cost of setting up digit names is expensive, and so we don't want to do it if it's never called. So they do a thing where they'll assign to digit name a function which will initialize the thing, and then after it has initialized itself, it will replace the value of digit name with a different function. And the justification for this is it will be faster in the case where it never gets implemented. It never gets called. The problem is it breaks the first classness, breaks a relationship of names with the function that's going to be using names. Because We could take the value of digit name and put it someplace else. I can pass it as a parameter to someone else. I can store it in an array. I can put it in a different variable or so on. So now, every time I call that version of it, it will reinitialize itself because digit name gets changed, but the thing over here didn't, and so it's constantly getting reinitialized. So we have lost a really important property of the language in doing that. And I'd recommend not pursuing styles that do that. Now, if we want to do the thing where we don't initialize a structure until it's needed, there's a different way we can write that. So here, we're going to have a variable called names, which initially is not initialized. And if we see that it's not initialized, then we'll initialize it. But because it's always bound in the closure, that problem of our not observing that it's changing can't happen because nobody else can get at names, and so that confusion can't occur. Yeah. No, because this names is within a function scope, so it will never collide with the global names. That's why this pattern is so important. So you could argue that this one has a performance cost versus the other one, but the cost is one if statement per invocation, which is in the noise. That's not a concern. Now you could argue, well, if you're going to call this function 1,000,000 times, the cost of 1,000,000 if statements might add up to something, but it turns out if you do anything 1,000,000 times in a browser, you're going to die long before you observe this kind of thing. But also, if you're concerned about what happens when you call it 1,000,000 times, why are you worried about the case where it never happens at all? It seems really inappropriate optimization going on there. Yeah, so some people will put it here. I recommend putting it there. And the reason is that either is sufficient for getting stuff past the compiler, right? But I want it to be meaningful for the reader as well. And so wrapping the function in parens doesn't really tell me anything, right? What I want to tell to the reader is this whole expression, this whole invocation expression, which is kind of unique. You don't see invocation expressions in other languages. So I want to call that out. So I want the invocation parentheses to be within that whole context. So I prefer this form. So you can think of scope as sets, right? What a function can see, what variables it's able to access, can be represented as a set. But the thing that is maybe counterintuitive is that it's inside out of the way it's written as a program. So the inner function is actually the outer circle in the scope diagram. And I've seen really smart guys get confused by this. I was at the hackers conference last year, and there's someone said, you got a bug in this slide. And I said, no, I actually don't. That's the way scope works. It's inside out of the source representation. So who would like to see another example of how you can do stuff with closure? Anybody? We can skip this one if you want. Okay, we got some nice hands went up. Okay, so this is going to be a fade function. Fade will take the ID of a DOM element, and it will modify its colors over a little bit of time, changing them from yellow to white. And the purpose of this is to draw attention to something maybe that's changing so the user can see it. So step one, so we call fade, we come in with our argument. We go to the DOM and get the DOM element corresponding to that ID. We'll talk about the DOM much more next week. And we'll create a variable called level and set it to 1. Then we'll create a function called step, and then we will call set timeout, having it call set in 1/10 of a second. And then we return, and that's it. That's all fade does. Fade is now finished. It has done its work. Suddenly, 100 milliseconds later, step starts running because it was triggered by set timeout. So first thing it's going to do is go to the level variable and change it into base 16. Level is 1. It's not the value of level at the time the function was created, it is the actual value. Because later down here, it's going to change it. It's going to add 1 to it. It's not adding 1 to a copy. It's adding 1 to that variable that belonged in the outer scope. It's then going to go to the DOM node, the same DOM node that it got from the outer function, and set the background color in that. It's going to look at the level, and if we're not done yet, it's going to increment the level and call set timeout to go again. And then it returns, and it's finished. And then we come back a tenth of a second later and do that again and keep doing it until it's done. Because of closure, all of the stuff that Fade needs to know as it's doing its work is encapsulated inside of that scope, so it doesn't leak out. So I could call Fade on 2 elements at the same time, go fade, fade, and they're both going to cycle through the stuff. They're both going to be getting time increments. They're both going to have independent levels, independent DOM, so they will not interfere with each other. So one of the nice things about closure is that we can set up contexts and, in fact, have as many instances of these contexts as we want. Every time we call something, we create another set of stuff, and when it's done, it all gets garbage collected, so you don't have to manage any of that. Right. Because every time a function is invoked, it gets its own activation in which, control its own variables. So Fade will create, when you call Fade twice, you'll get 2 activations, each containing its own DOM and element and step functions. The same way it would if we were doing it recursively, right? If you have a recursive function, each time you re-enter the function, you're getting a new set of stuff. This is happening the same way. It's using the same mechanism that functions can do. New does create new objects, and we'll talk about better ways of creating objects. But in this case, we're not creating an observable object. You can't observe the activation record that happens when you invoke a function. But that's what we're doing. And that's where these variables live. So every time we call a function, we get a new clean set of variables, which are distinct from all of the other invocations of that function. Okay? So that's repetitive. We'll skip that one. We'll skip that one. Okay, so when Brendan Eich designed JavaScript, he was influenced by something called delegation or prototypal inheritance. It was something that came out of a language called Self, which was a improvement over Smalltalk. But while there were some researchers who were very excited about the concept, it had not found its way into the mainstream. But he thought it would be a fun thing to put in his language, which was amazing that he was creating a language for beginners, but he was putting all these sort of underappreciated research ideas into it. Obviously, nobody at Netscape was paying attention to what he was doing at the time. He should not have been able to get away with that, but he did. And I'm kind of actually glad that he did. So he only had 10 days to build the language, which was way too short a time, especially when he's taking new ideas which really haven't been proven in practical application yet and putting those in the language and inventing syntax for how they should work. So given that process, not surprisingly, it didn't turn out very well, at least at the surface level. So this is how he proposed objects would work in JavaScript. And this is the understanding that most people have using the language. So we're going to make a gizmo. A gizmo is some kind of generic object, and it will take an ID. And this is the gizmo constructor. And the gizmo constructor will create an ID element or ID property in the object and initialize it to the ID value. And then gizmo.prototype, every function is an object in this language, so objects can have properties, and one of the properties that functions have is prototype. We'll add something to the prototype object called toString, and that'll be a function that will return a string of the ID concatenated with the word gizmo. And the Java guys looked at this and said, my God, what is this? What is this prototype thing? Why is it hanging outside of the class? Is this a class? What, it's just awful. Everybody hated this from the beginning. It's like, what is this? So this is what's going on. So we've got our code up there. That's the stuff that we just looked at. So when we call new gizmo, passing in a string, we're going to make a new object. And, well, okay, let's look at the relationships. So first, gizmo is a function. And that function contains a prototype property. And that prototype property links to gizmo.prototype. So this is gizmo.prototype. And gizmo.prototype is where we put the string method that we created there. And also, by default, it contains a constructor property, which contains a link back to Gizmo. That's so you can look at something and ask, what is your constructor? And that will point you to where it came from, which is not a practice I recommend, but you can do that. Then the system does this itself. So there is a function called object, which is a global function. It's the constructor for all objects. And it contains a prototype, which points to object.prototype, and object.prototype contains a constructor property that points to object. Okay, everybody with me so far? Now we're going to create our gizmo. And the gizmo contains an ID, and it also contains a secret link, a link that ordinarily doesn't have a name, to Gizmo's constructor, or to Gizmo's prototype. So it points to gizmo.prototype. So if I go to the object now that I've created and I ask for its .id, I get its string. So Brennan's insight was if we replace the original prototype object, then we can inherit another object stuff. So here's how he did that. So we're going to make a whosit. A whosit's going to inherit from a gizmo. So its constructor looks very similar. We're going to have an ID field. And then we'll replace whosit.prototype with an instance of gizmo. So we'll say new gizmo here. And the Java guys looked at that and they howled. They go, what? That's not extends. What the hell is that? That doesn't make any sense. And then we can go on and enhance whosit.prototype, adding additional methods, make it useful. So, yeah, that's awful. So let's look diagrammatically what's happening here. So we've got our gizmo function, which has its gizmo.prototype. We've got our whosit function, which had its whosit.prototype, but we replaced it with an instance of gizmo. So when we put in the diagrams, it's a little bit more convoluted, but you can see what's going on. So if I've got my object and I ask for ID, I get it here. If I ask for its test method, I'll get that here. And if I ask for its toString method, it'll go and get it here. Okay? So the inheritance part's okay, but the notational part is just kind of awful. Yeah, so this, I call this pseudo-classical inheritance, in that it's not classical, but it's trying to look classical. And the Java community just looked at this and said, no way, I don't know what this is, but this isn't object-oriented. In fact, for many years, people thought JavaScript was not object-oriented because people couldn't figure out what the hell it was doing. It turns out it is object-oriented, where you can have objects inheriting from objects. What could be more object-oriented than that? But from this notation, nobody could figure out that that was actually what was happening. So one thing you could do is wrap this in macroids, functions that kind of act like macros to give us syntax that's better. So we could create a new constructor function, and we'd pass in the object that we're inheriting from, and then pass in the constructor function, and then pass in an object containing the methods that we want it to inherit from. So in this notation, this starts to look a little bit more rational, right? You can almost recognize this as a programming language. And it's easy to implement. So this is a function that causes that to happen. Is this better? Well, clearly the first form was awful. So, at least notationally, this is an improvement. But it, I think, makes it even easier to distract yourself from what this language can actually do. So working in this paradigm, you're not making best use of the language. So in that respect, I think maybe it's not better. So we've already talked about using functions as modules, right? We saw that in the digit name example, where we can create stuff inside of a function that doesn't leak out, and we can do interesting stuff with that. So this is the module pattern. This is I want to create an object that contains two methods, first method and second method, and I want those two methods to be able to share some private state, my private variable and my private function. If you didn't understand how closure works, then these would have to be global variables. That's the only place you could put them where they could be shared by a function. And we already know global variables are evil. We want to stay away from that. But by putting it in an immediately invoked function expression, what we're assigning to the singleton, again, is not the outer function, it's its return value, which in this case is an object. And we have two functions now that are closing over the same stuff. Because they're both closing over it, they share it. Yeah. So we can take that module pattern and turn it into a constructor pattern. Basically just by making it a form where we can call it more than once, it becomes a constructor. So here's the recipe. We'll make an object using any of the techniques that the language provides, like object literals or new, or object.create, which is actually the primitive which makes a new object that inherits from another object. This should have been in the language from the very beginning, but it didn't get added until ES5. It was late. Or we could call another constructor and take its object and use it as the input to our constructor. Then step 2, we'll define some variables and functions, and these will become the private members of our function. Step 3, we will augment the object with privileged methods. A privileged method is a method which closes over the private state. And then step 4 is we return the object. So a really simple recipe, maybe a little abstract here, so let me turn it into a template, make it a little easier to see. So step 1, I'm going to create a power constructor. And I'm going to create a variable called that, and that will contain the object that we're constructing. I'd like to call it this, but this is a reserved word, so I'm going to call it that instead. In this case, I'm going to use some other function to start the initialization. That actually gives me another dimension of inheritance, because my object will inherit whatever it is that he did. That's fun. Then I will create my secret variable, and I could initialize it now, or I can initialize it later, it doesn't matter. Then I'll create my privileged methods. The privileged methods, because of closure, will have access to the secret, or secrets that I create. We'll have access to the parameters that got passed into the constructor, and we'll also have access to that. And then I return that, and that's it. So this is a really nice way to make objects in JavaScript. For a long time, it was thought that we couldn't have private members in objects, but it turns out we can. If the only way you can access the privacy is through the privileged methods, then it's private. And there is a cost because, relative to the prototypal inheritance, because we're creating a set of privileged methods for each object that we make. That is a cost, but unless you're making hundreds of thousands of objects, it's not a meaningful cost. Yeah. So we can redo this using that functional form with power constructors, and it turns out a lot better. I mean, we can avoid stuff like here we've got Gizmo inheriting from whosit, but whosit had to repeat the initialization in the constructor. Now, that doesn't make sense. That's wasted effort. And then you have all that other stuff. So we can do better than that. So I'm going to write my Gizmo now, and it can be really simple. So I'm just going to use an object literal. I'll return an object literal, and it'll contain the ID, and it'll contain the toString method, and I'm done. That's easy. So this code is way better than the previous code we were looking at. Then I want whosit to inherit from it. Okay, so whosit will call the gizmo constructor, assign that to its that. It will then create its privileged method, its test, and return that, and it's done. So that's really simple. And this code is so much better than the other code, right? We don't have stuff hanging out. It's smaller, it's cleaner, this is elegant. This is good stuff, compared to the other one, which is ultra crappy. But we can do even better than this. So one flaw that all of these had was ID was a global property, or a public property. And I want it to be a private property. I want people to only be able to access it through my privileged methods. I don't want anybody to be able to look at it or modify it unless I want them to. There was nothing I could do in the prototypal or in the pseudo-classical form to accomplish that. But I can do that really easily here and actually get smaller and faster. So I'm using closure now, okay? So I don't even need to put it in this. It's just this function will close over ID, and so it's got it. Boom, the program got smaller. And a similar thing happened down here as well. Because I'm passing the same ID into who's it, and he passes it back to Gizmo, it happens it's in both closures. So both toString and test both get it. It's just really clean, really nice. So this is a nice pattern. Yeah.
You're going to create multiple copies of the function now?
Yeah, so I'm making multiple copies. So I'm going to have an extra toString method. Every function, every object will have its own toString method in it. And again, unless you're making hundreds of thousands of instances, it just doesn't matter. Function objects are lightweight. Objects in this language are much, much lighter weight than they are in Java. It's not a significant cost. Now, if you are making hundreds of thousands of instances, this is probably not the language you should be working in anyway. So that's not where you want to be optimizing. Then there are other tricks I can play. So if I wanted to have some shared secret, sort of the equivalent of package scope that could be shared between things, I could do that. I could explicitly pass in a secret object which gets passed back and forth between all of these guys where they can keep this package state. I don't recommend that, but we can do that. Another thing we can do is super methods. Now, in the classical forms, super methods are really important. You can't imagine having one thing inherit from another without being able to wrap super around its methods and do other things. So when I started working in JavaScript, I came up with patterns that allowed me to write super methods, and I've never used them. So I've been writing in this silly language for, what year is this? 13, 14 years. I've never once needed a super method. So from that, my opinion is that if you think you need a super method, you're not writing in the language you think you're writing in. Because in the classical languages, the principal code reuse pattern is inheritance, right? But inheritance doesn't always do what you want, and so sometimes you have to super in order to get what you want. JavaScript, it turns out, composes in so many ways that in the cases where you think you need supers, there are better, more convenient, more efficient ways of doing it, and I found you just don't need it. If you had to have it anyway, there's a pattern within this to accomplish it. It's slightly ugly, but it works. But, the better news is it's completely unnecessary. One of the things that all of this affords you is higher order functions, where you've got functions that act on functions. So this is an example of a memoizer. A memoizer is a function that takes a function and creates a memoization or a memory of all of its results. And so if the function it creates is ever called asking for a value that it has already computed, it can go to the memoization table and avoid having to do that computation again. So let me walk you through this because this is kind of neat. So we've got our memoizer function, and it will create a function called recur, which it will return, and that's it. That's all it does. So let's use it. I'm going to create a factorial function by passing the first two values of factorial. Factorial of 0 is 1, factorial of 1 is 1, and a function which computes all of the other values. And it will take as a parameter a recurrence function, which it will use in order to call itself recursively if it needs to. So the formula is n times the recurrence of n minus 1. That's the definition of factorial. So when we call recur, we come back here with our argument, say it's 2. We'll go to result and look it up in memo. Does memo of 2 exist? No, it doesn't. If it did, we'd just return it and we'd be done. But it doesn't, so we're going to have to call the formula function, and we'll pass the recurrence back again. And when it returns a result, we'll store that in the memo. So this really pays off when we do Fibonacci. The recursive definition of Fibonacci is you recur on n minus 1 and add that to the recurrence of n minus 2. And if you try to compute this, using ordinary functions, the tree grows really wide, really fast, and it gets intolerably slow after dozens of iterations. Whereas by using the memoizer, it becomes linear. You never compute a value twice, so it's always, boom, really, really fast. So often when we think about how do we make things go faster, it's usually by trying to squeeze the code, but sometimes what you need to do is rethink what you're doing. And one of the nice things about higher order functions is you can have functions which make it easier to write functions. And this is a really nice example of that. One warning about functions. In JavaScript, you can create functions anywhere. Any place you can have a function or an expression or a statement, you can create a function. But I recommend you do not create functions in loops, even though the language is happy to let you do that, for 2 reasons. One is it is wasteful, because a new function object will be created on each iteration. If you're afraid to be putting functions into objects, you really don't want to be wasting them in loops. But there's a worse problem, and that is the new function that you're creating closes over the loop's variable, which has been hoisted to function scope, not over its current value. And so that can very easily lead to bad code. So this is something I've seen a number of times. It was a loop that's intended to loop over an array of divs and want to give each one an onclick handler where when you click it, it will do its number. So if there were 10 divs and you click on them, each one will say 10. It won't say a number between 0 and 9. And you could look at that code in a while and say, what happened? Why aren't they getting my numbers? And it's because you're not closing over the current value of I, you're closing over I itself. And so by the time you finally go to click on things, you're closing over its final value, which was 10, which was what it was when the loop was exhausted. So it turns out the solution to all of our problems is always to write another function. And that's the solution here. So I want to move this function out of the loop and put it inside of another function which will create the handler for me. And I will then pass in the ID that I want it to close over. And this solves it. So now each time through, this function will close over that, not over I, which is constantly changing. And because nobody ever changes that one, it gets a constant, which was what we wanted in this case. So the moral of that is never create functions in a loop. So JavaScript has good parts, and I think the best of the good parts are its implementations of functions and the way they interact with prototypal objects. It is because of that interaction that I think this is an interesting language. For more information on JavaScript's schemish nature, there's an amazing book called The Little Lisper that teaches recursion in a dialect of Lisp or Scheme. And it's one of these books, it's a little tiny book, but it will expand your mind and take you places you've never been before. If you haven't read it, I highly recommend it. This is a link to a description of the book. You can get it on Half, I'm sure, and other good places. Probably pay for it on PayPal, I would imagine. There's a newer edition of it called The Little Schemer. That's what it's known as now. It's been modified and brought up to date a little bit. Again, highly recommend reading this book.